Hello, so we're going to continue working on the chemical bonding units. So today we're going to talk about the nomenclature or the naming of variable charged ions. Just kind of before we start, this is where, in my experience of teaching this subject, where it becomes very, very confusing for most students. So if after this video you still have no idea what in the world I'm talking about, please come talk to me, email me, whatever you need to do, because it's very important for you to understand this and be able to distinguish between certain rules in regards to bonding. So again, if you have any questions after this, write down some questions, come talk to me, and we'll figure it out together. So variable charged ions focus mainly on transition metals, and the reason why is because the charge of a transition metal cannot be identified by just observing the pure metal itself. They can have different charges. Transition metals can form both positive and negative ions if needed. It really depends on what it's being attached to. So these different charges are what's called oxidation states. I'm not going to dive further into what oxidation states are, but if you hear me say oxidation state, it's the same thing as saying what's the charge of that ion or the particular charge of that ion. Sorry about that. The only way to identify the transition metals or the charge of the transition metals is analyzing what the compound it's a part of. So what we do is that if it's a covalent molecule or ionic compound, we see how the metal is arranged with the atoms in it in regards to bonding, and based off the charges of those other things or how the electrons are manipulated, we can determine the charge of the metal itself. So in other words, to identify the charge of the transition metal, we have to identify the charge of what the transition metal is attached to. Because the thing is that those compounds and covalent molecules want to be neutral in charge. So if we identify what the transition metal is attached to, and then we take the exact opposite charge of that, that must be the charge of that transition metal. So for this class, you'll be responsible to identify the charge of the transition metals if given a compound. So you should be able to look at a compound, and based off what you see in that compound, you can say, oh, the transition metal has a charge of this. You also will be responsible to identify the charges of select transition metals, so you can create chemical formulas from a given chemical name. So if I give you a chemical name, based off that name, you should be able to tell me what the charge of that metal is and determine the chemical formula. But 99% of the time, you'll be working with transition metals that are cations. There might be one or two that actually has negative charges, but a majority of the time, it's going to follow the same trend as metals forming cations. So the naming systems with variable charged ions. Due to the fact that transition metals can produce variable charged ions, ions of different charge, we have to have a new system of nomenclature to account for that. So there's two major naming systems that we're going to go into. One's called the stock system, and another one's called the classical system. The stock system, it utilizes Roman numerals to indicate the charge of the transition metal cation or anion, in this case, within the chemical name. So the Roman numeral is going to be placed after the name of the cation, and then the name of the anion follows the same rules of ionic compounds. So you're following the same rules of ionic compounds where it's the name of the metal and then the name of the anion. It's just you have to have a charge in between it of a Roman numeral. So if I look at iron 2 oxide, what it is, it's FeO. And the reason why is that oxygen, we know, forms a -2 anion, but for it to be a neutral compound, then that anion has to be canceled out by a +2 charge. So iron has a +2 charge, which is the reason why we use the Roman numeral 2 within the formula name. Excuse me. So it has iron 2, which represents iron 2 plus oxide. This one's a little bit different. So the thing is that since iron has a different charge, iron has a +3 charge, then you do the crisscross method, and now this forms iron 3 oxide. So they look similar, but two completely different things. So that 2 from the anion of oxide comes down as the subscript for iron, and then the +3 charge for iron goes down to form the 3 subscript for oxygen. Copper 1 chloride, we know chlorine makes a -1 charge, so if there's no subscript here, then we have to assume that copper has to be +1 to neutralize the charge in that compound. So again, name of the metal, cursor, name of the metal plus the charge indicated, so copper 1 plus chloride, which is the anion. Same thing with this one. So since there's a 2 here, we know that the -1 from chlorine goes down to form the 1 here in the crisscross method. But this 2 had to come from the charge up at the copper level. So since copper is on the left-hand side of the formula, we know it's a cation, so it has to be 2+, so that's where you get copper 2 chloride. Then we get to the classical system. The classical systems, the reason why we still teach this is because a lot of chemical bottles and stuff that you'll buy can have both the classical system and the stock system on it, or it can have either or. So you have to be able to read both of them. The classical system is classical because it utilizes the Latin root, or the root word of the element, for two distinct suffixes for the cation. So it uses a lot more suffixes and more Latin roots that you may not even be familiar with, but it's something you need to know, because if you go to read a chemical bottle and it has the classical system on it, you need to know what you're working with. So the suffixes, there's two particular suffixes. One ends in "ic," which indicates a cation or a metal ion with a higher charge. Okay, so one of my colleagues, when I was in student teaching, the way he would say this is that if you're a kid, you know, your parents would always put the icky stuff, the stuff that they don't want you to have, on the higher shelf. Okay, the second one is OUS, which indicates lower charge. So the stuff for us, OUS, would be on the lower shelf. So that's how he would describe it. I saw it worked with a lot of kids. If there's another way you want to try to memorize it, go for it. But just think icky stuff is on the higher shelf, which means higher charge. OUS is the stuff for us, which is on the lower shelf, which is lower charge. So the element cations that utilize the Latin root word, copper uses cuprum, which is the Latin root word for that. Lead uses plumbum. I know that sounds weird, but plumbum. Tin is stannum, which is where SN for tin comes from. So if you're wondering why tin has SN and not Ti like titanium, that's the reason why. And the same thing for lead. Lead is PB, okay, instead of like LE. So that PB comes from the Latin root word of plumbum. Iron, same thing. Fe comes from the Latin root word of ferrum. So a couple examples of how this classical system is used. If I use the exact same formulas from the last slide, iron 2 oxide becomes ferrous oxide, okay? And then the Fe2O3, the iron 3 oxide, since it has the higher charge, becomes the ferric oxide, okay? So it still follows the same thing. It's just you have to change the Latin root words to fit either the "ic" suffix or the OUS suffix, and then it's just the name of the anion after. Copper, since it had the 1 charge compared to the 2 charge, copper 1 chloride becomes cuprous chloride, and then copper 2 chloride becomes cupric chloride. And then another one is just nickel. Nickel is another one that has variable charge, so you can see Nicholas chloride. Sounds like an actual human name, but Nicholas chloride is a thing. Okay, so there are a select few of variable charge ions that you're going to have to remember and what type of charges that they can hold. I'm not expecting you to memorize all the transition metals on the periodic table, because a lot of them have really weird charges that you don't even want to deal with. But the most common ones that you're going to come across in your life and in this class are the ones I want you to memorize. So I've broken it down into 3 distinct charts here. One is for the Roman numeral of 1 or 2, where they're +1 and +2 charges that these elements can have. And then you have 2 and 3 for the +2 and +3 charges, and then the 2 and 4 for the +2 and +4 charges. So the ones that have +1 and +2 charges is copper and mercury. Now, one thing you need to know is that mercury 1 plus, has a +2 charge and a 2 subscript. The reason why it's called mercury 1 is to form this 2+ charge, there are 2 mercury atoms, which means each mercury atom has a +1 charge, which adds up to the +2. The mercury 2+ has no subscript, but it has the +2 charge. So both mercuries have +2 charges, but mercury 1 is the one that has the subscript of 2. Mercury 2 is the one that does not have it. Okay, so that's a little confusing for a lot of people, but just be aware that's how it works. I can illustrate that further in class if you'd like. Just come and ask me, but that's what we're looking at. The next one are the longer list, so it's the 2 and the 3s. So you have chromium 2+ and 3+, manganese 2+ and 3+, iron 2+ and 3+, cobalt 2+ and 3+, nickel 2+ and 3+. Okay, so a majority of them are going to be 2 and 3+. And we'll probably see these the most throughout the class, but just be aware of that. And then you have the weird ones, which is 2 and 4, where they kind of skip a little bit. And that's 10. So 10 SN is 2 plus and 4 plus, and then lead is 2 plus and 4 plus. Okay, so please write this chart down somewhere. That way you can start memorizing it. Use flashcards if you need to. Come talk to me. Maybe we can figure out another way that I can help you memorize it. But you need to know these before you move on, because if you don't, you're going to have trouble with the next stuff that's coming up. All right, that's it for this video. So if you have any questions or anything, feel free to come talk to me, email me, whatever you need to do. It's very important that you get this, because now you're going to start getting to a point where you're starting to mix rules or mix things. You'll start taking variable charged ions plus polyatomic ions to apply the ionic rules of those, and so on and so forth. So if you have questions, please come talk to me. Or if you don't want to come talk to me, talk to a friend that can make sense to you, whatever works. Just make sure you can get this information down, because it's essential. If you don't get this, you're going to have a hard time throughout the course of the year. But otherwise, thanks for joining me on this video. Hope to see you in the next one, and see you in class. Bye.